Welcome back. This is Mr. Hassan's Maths channel, and we are now on question number 4 from the January 2021 International A-Level Edexcel S1 paper. This question here is about discrete random variables, and we have a spinner which can land on the numbers 10, 12, 14, 16 only, and the probability of the spinner landing on each number is the same. The random variable x represents the number and the number that the spinner lands on when it is spun once. State the name of the probability distribution of x. Well, each of these will have the same probability because it's equally likely to land on each number. So each of them will have the probability of a quarter because there's 4 of them. This is called a discrete uniform distribution. Discrete because it's discrete numbers. Uniform because they're all the same. So a discrete uniform distribution. That's the name of this probability distribution. Okay, then it says B part 1 says write down the value of Ex. Well, because all the probabilities are the same, the expected value or the mean is going to be basically the mean of these numbers, which is 13. It's halfway between all these numbers, okay? Because it's symmetrical. It's not only symmetrical, it's uniform. All of these are the same. So the value of Ex is going to, we can just straight away it's going to be 13, halfway between 10 and 16. Now we've got to find the variance of x. Now the variance, what I'm going to do is I'll make a little table which I have kind of prepared earlier to make it a bit neater. So I'll take this table and I'll just make a quick probability distribution. I don't actually have to do this, but just for the sake of neatness or whatever. So I know that we got x and we got the probability that x equals that particular value of x, and we have the values of x are 10, 12, 14, 16, and all of them have a probability distribution. All of them have the probability of a quarter because there's 4 of them. And we want to find the variance of x. Now the variance of x is equal to the mean of the squares minus the square of the mean. Okay, the mean of the squares minus the square of the mean. We already found the mean is 13, so I've got to do 13 squared here. But what is this Ex squared? Well, it's going to be this number squared times a quarter, plus that number squared times a quarter, plus that number squared times a quarter, times that number squared times a quarter. So all of them will be multiplied by a quarter. So it'll be a quarter times, I'll just take that quarter out as a factor. You're going to have 10 squared plus 12 squared plus 14 squared plus 16 squared minus, and you're going to have Ex, which is 13 squared. Okay, so that will give you the variance of x. This is the variance of x. The mean of the square, the mean of the squares minus the square of the mean. Okay, the mean of the squares minus the square of the mean. Nice, easy to remember. Okay, so now we're going to put that in our calculator. So we're going to have basically, it's going to all be over 4. 10 squared plus 12 squared plus 14 squared plus 16 squared over 4 minus 13 squared minus the square of the mean, and that should give us our variance, which is 5. So the variance is equal to 5. So we can say the variance of x is equal to 5, and we know Ex is equal to 13. Okay, so there we got the answer for part B. Now for the next part here, it says a second spinner can land on the numbers 1, 2, 3, and 4, and 5 only. The random variable y represents this represents the number that the spinner lands on when it is spun once. The probability distribution of y is given in the table below, so they're not all equally likely this time. So first we've got to find the expected value of y. So this time it's not going to be right in the middle. If they were all equal distributions, then it would be right in the middle, which would be in 3. But now they're not equal, so what we have to do is we have to basically multiply each of the random variables by its probability and then find the sum of all of them. And that will be the expected value of y. Sorry. So 1 times 4 over 30, which is 4 over 30, plus 2 times 9 over 30, which is 18 over 30, plus 3 times 6 over 30, which is also 18 over 30, plus 4 times 5 over 30, which is 20 over 30, plus 5 times 6 over 30, which is 30 over 30. So if we add all of these together, we're going to have 50, 68, 68 plus 4 is 72, 72 plus 18 is 90, that's 90 over 30, which equals 3. That's the expected value of y. So EY equals 3. And now we've got to find also the variance of y. Let's make a bit more space, put this up here. So the variance of y is basically where you square the number, square the random variable, and multiply it by the basically it's what we said. It's the mean of the squares minus the square of the mean, as we did up there. Okay, so what we can do here is we can square each of the values of y, multiply by the probability distribution, and take away 3 squared from the answer. So this is going to give me 1 times 4 over 30. So that's the same, 4 over 30. So that's going to be 4 over 30 plus. This is going to be 4 times 9 over 30. So remember, y squared is 1, 4, 9, 16, 25. So I'm going to have 4 times 9 over 30, which is 36 over 30. Plus, I'll have 9 times 6 over 30, which is 54 over 30. Plus, 16 times 5 over 30, which is 80 over 30. Plus, I'll have 25 times 6 over 30. Now, 6 times 25 is going to be 150, isn't it? 150 over 30. Okay, so what's that going to give us? That's going to be 150 plus 80, which is 230, plus that's going to be 90. So 230 plus 90 is going to be 320 plus 4. So 324 over 30. Let me just make sure I didn't make a silly mistake there. I have 4 plus 36 plus 54 plus 80. That's right, 50 plus 30, 80 plus 6 times 25, 150. That gives me 324 divided by 30, which gives me 54 over 5. 54 over 5 is is the variance of. I haven't finished yet. Sorry, I've got to take away from this 9. Okay, so let me just put that in the same part. This is this was, sorry, what we found just now. This was equal to 54 over 5. This part minus, and you're going to have the mean of y, which was 3, minus 3 squared. Okay, so 54 over 5 minus 9, and that gives us 1.8. Okay, so we can say the variance of y is equal to 1.8. So that's the expected value of y, and that's the variance of y. Okay, so there we've done question number, was it 4, part C. Okay, now for part D on the next page. Okay, now for part D, we have some of the information from the last question, or the last part of the question that we might need. It says a random variable w equals, so w equals a x plus b, where a and b are constants and a is greater than 0. Given that EW equals EY and variance of W equals variance of Y, find the values of A and B. So if W equals AX plus B, then I can say that the expected value of W is equal to E times AX plus B. All right. So I can say the expected value of W is equal to, now this is a linear transformation of the value X here. Okay, so what you can say is, when you've got something like this, that E times AX plus B will be the same as A times EX plus B. So you multiply EX by A and you add B, it will give you the same thing as AX plus B. And I know what EX is. EX is 13. So this is going to be A times 13 plus B. So that gives us EW is equal to 13A plus B. And we know that EW is equal to EY. So EW is equal to EY. So the expected value of W we know is equal to the expected value of Y, which is equal to 3. Which is equal to 3. So therefore I can say that 13A plus B is equal to 3. So that's one equation I've got with A and B. And I can find another equation with A and B by using the other bit of information that they told us about the variance. They've told us that the variance of W is equal to the variance of Y. Okay, so I can do something similar here. I can say the variance of W is equal to, okay, the variance of, now, sorry, yeah, the variance of W, I know W is equal to AX plus B, so I can say the variance of W is equal to the variance of AX plus B. I can use this, right? The variance of W is the same as the variance of AX plus B, and what you know is for the variance, it's not affected by addition and subtraction, because this is about the variance is about the spread of the data. So it's only affected by the multiplication. And the standard deviation, you know, if you multiply all the values by a certain amount, then the standard deviation changes by that same product. And the standard deviation, or the variance, is a square of the standard deviation. So the variance will be affected by being multiplied by the square of that product. So whatever's multiplying the values of x, you have to square that and multiply by the variance of x. So it's going to be a squared times the variance of x, and you're not going to add or subtract anything to it because that doesn't change the spread, and variance is about spread of data. So we know this particular situation here, right? So I know the variance of W is equal to the variance of Y, and I know the variance of Y is equal to 1.8. So I know the variance of W is equal to the variance of, the variance of W is equal to the variance of Y, which is 1.8. So I can replace this with 1.8. Okay, so I can say that a squared times the variance of x, okay, and another variance of x is what? 5. Okay, the variance of x is equal to 5, so a squared times 5 is equal to the variance of W, which is 1.8. So you're left with 5, a squared equals 1.8, so a squared equals 1.8 divided by 5. So you're going to have 1.8 divided by 5, which is 9 over 25, which is 3 over 5. So a is equal to 3 over 5. They told us that a is greater than 0 because a could have been minus 3 over 5. If I take the square root of 1.8 over 5, I could have plus or minus 3 over 5. But they told us that a is a constant positive. Okay, so we know that it's 3/5 exactly. And therefore we can find b. We have 13 times 3/5 plus b equals 3. So b equals 3 minus 39 over 5. So you have 3 minus 39 over 5. Which gives us minus 4.8. Okay, so it says find the value of A and B. So we know A is, let me just make some more space here. So we know that A is equal to 3/5, which is 0.6, and B is equal to minus 4.8. So there we have the answer for part D. Then it says for part E, it says each of the two spinners is spun once. Find the probability that W equals X. Okay, so let me get the values from the table from before. Okay, so this is the information we have from previous questions, including the values of A and B up there. It says each of the two spinners is spun once. Find the probability that W is equal to X. So basically W is the same as AX plus B, which is 0.6 A minus 4.8. Okay, so 0.6x, sorry, times x minus 4.8. A is 0.6. Okay, so what I'm going to do is I'm going to see for every x value what W is going to be. So when x equals 10, W is going to be 0.6 times 10 minus 4.8, which is going to be 6 minus 4.8, which is going to be 1.2. So there's no y value, which is 1.2. So that won't help us. X equals 12. The W is going to be 0.6 times 12 minus 4.8, which gives us, that's going to be, let's just show what that gives you. You're going to have 0.6 times 12. Oops, 0.6 minus 4.8. That gives us 12 over 5, which is 2.4, which again, there's no y value that matches that. W equals y, W equals 1.2. There's no y value which matches that. There's no y value that matches this one either. Let's try with 14. So just replace that 12 with the 14 now. Again, we get 3.6. That's going to give us W equals 3.6. When x equals 16, W equals, let's change that to 16. .8. Okay, as we can see here that there's no value for W which matches any of the values of y over here. Okay, there's no value of W which matches the value of y over here. So I can't get any value which will be the same as these. Okay, so each of the two spinners is spun once. Find the probability that W is equal to y. Okay, so the W value is based on what x is. It's 0.6 times x minus 4.8. So the values of W are going to be either 1.2 or 2.4 for the first spinner. The values of W are 1.2, 2.4, 3.6, and 4.8. Okay, and there's no value of y which matches those. So the probability that the probability that W is equal to y is going to be 0. There'll be none of them will be the same, and that's the answers for part E. Okay, none of the W values match any of the y values. So there'll be no the probability that W will be the same as y, that the random variable W is equal to 0.6 times whatever x comes up minus 4.8. That's what the value of W is going to be, and all of them are non-integer values, and all the y values are integer values. None of them are going to be the same. Therefore, the probability that W equals y when each of the two spinners responds once is equal to 0. You'll never get the same value for W and y. Okay, and that's the answer for that question, and that completes the whole question, I think. And that's question number 4. Other questions from this paper you'll find in the playlist that should appear over here. Other questions from this discrete random variables topic will be found in this playlist. You can subscribe to my channel by clicking on this link, And at the top of the page here, you can find a link that takes you to another S1 paper. Thank you for watching.